Hi everyone, my name is Nishchal. I'm a PhD student at NC State University, and today I'm going to talk about our paper, Here We Go Again. Why is it difficult for developers to learn another programming language? First of all, I'd like to give big thanks to my co-authors, Colton Boda, Titus Barik, and Chris Parnett. I'm going to start with the problem, and that's the fact that developers have to constantly learn languages. To give you an example, here's a Java programmer in a company trying to consider Kotlin as a code base for their project. And they are proficient in Java and they're learning Kotlin for the first time. So they find that some things transfer over very well, such as static typing and object-oriented programming. However, they also come across differences immediately in that Java types precede names, whereas in Kotlin, the types follow names. And Java classes are not final by default, and Kotlin are final by default. And a programmer like this has to go through this process over and over again as they consider different languages. And our paper is basically motivated by this question of why can previous knowledge sometimes make it difficult to learn programming languages, which seems kind of counterintuitive, and how do we begin to understand this issue? So we turn to interference theory, which describes the ways in which memory can either facilitate or interfere with new information. So to give you an example, let's say you go to your grocery store to pick up some bread, and you go walk up to the aisle that is located for that bread, and instead you find that it's a sauce aisle now. And so they've moved the bread aisle, and your previous knowledge actually interferes with this new information. And the next day you still go to the same location for the bread because that's instilled in your brain. On the flip side, let's say you're looking for this new Impossible Burger that's in the store, and you know it should be in the frozen section because that's where the meats are usually kept. And so you walk up to that section and you find the Impossible Burger there. And so in this case, your previous knowledge facilitates that new information. So we can look at this example based on that lens, right? So things that work from Java to Kotlin, we can call that cross-language facilitation. Things that don't work from Java to Kotlin, we can call that cross-language interference. And so the first part of our study, we decided to do an empirical study on Stack Overflow questions. And our main question here is, can we figure out whether cross-language interference is occurring at all in the wild? And so the way we did that was we looked at posts where two languages are associated, such as Python and R, and we filtered down the list of languages to 18 unique languages and 15 pairs. And for our analysis, we did a qualitative coding of 30 posts per pair, and our labeling heuristic was as follows. A post will be labeled correct if the asker is making a connection to a previous language with correct assumptions about the target language. And this is revealed by the accepted answer. On the flip side, it's labeled incorrect if they're making incorrect assumptions about that target language. So to give you an example, here's our programmer trying to program in Python for the first time, and they guess on an equivalent expression that they could accomplish in Python, but they get this weird setting with copy warning. And they even say, maybe I'm thinking too much in R terms. So this is an example of interference from the R side. And the accepted answer confirms this because they tell the asker, your statement is incorrect. You should actually be using this alternate syntax. So what are the results? Well, they're not all that great, even with the simple heuristic, in that 61% of the 450 posts contained incorrect assumption. Only 39% had correct assumptions. And some of these pairs, they're particularly prone to this, which is kind of odd because they're very similar languages in each pair. And some of these fare only a little bit better, right? So there's still a lot of questions in our mind. So we decided to do a phase 2 where we actually talked to professional programmers who are experienced in multiple languages, and they're going through some transitions. And so we asked, how do experienced programmers learn new languages? And what do they find confusing while they're doing this learning experience? And so we did semi-structured interviews with 16 participants and asked them about their background, the first steps in that language, obstacles that they came across, as well as their learning strategies. And for our analysis, we basically conducted thematic analysis on the transcripts and came up with some high-level themes to describe the learning strategies, and the confusions. So here's our results for RQ2, and I'm only going to cover these two. The first thing that we noticed was programmers didn't have formal training. So what they did was this foraging behavior, an opportunistic type of learning where they only learned things as they needed and looked for quick resources like cheat sheets and even other people's code. Related to that was the strategy of trying to relate the new language back to their previous language. And P10 says they loosely take ideas from working in another language, and P15 thinks that gets them more than halfway there. But as you can imagine, as you start doing this comparison, like in the Java Kotlin example, you come across interference. Some participants actually did a clean slate start when they were learning that language. So what do programmers find confusing in languages? Well, a bunch of different things. In total, we found 5 themes, but I'm only going to cover 3 that I think are interesting. The first one is that when programmers are switching languages which require paradigm shifts, they have to mentally change the way they program. And this is called mind shifts in the literature. Here, P5 is switching from C++ to JavaScript, and they weren't used to the type of asynchronous coding and the type of front-end coding you have to do in JavaScript. Related to that is the issue of little to no mapping to previous languages. So programmers who tried to do this comparison exercise were not successful when, for example, P10 says that Rust has a borrow checker thing, which is a very alien concept. It does not exist in C#. Finally, I'd like to point out that retooling is a challenging first step. I give this example because it's interesting. P9 actually went from JavaScript to Scala. They used IntelliJ to do their Scala work, and they say that part of the problem is that IntelliJ is aimed at the Java developer, but I'm using SBT, which is from the Scala world. And it's sort of importing SBT into the concepts of the IDE of IntelliJ. So I'm looking at dialogues that are all about Java and which JDK, and that doesn't really map to what I wrote in the declarative SBT language. So the final takeaway for this paper that I want you to have is that we talk about transitioning from language A to language B, when in fact it's actually also language A's ecosystem to language B's ecosystem. And so what are the design implications of that? What can technical authors, toolsmiths, and programming language designers do to help reduce these interference issues? So the first one we could do is enhance the documentation for these languages so that we reduce interference and support knowledge transfer. Here in the Rust documentation, they try to make analogies to C-style languages. So maybe this is something that languages can do. The other one is to build automated tools to provide on-demand feedback. A simple example is if you go from Python 2 to Python 3 and you try to execute print as a statement instead of a function call, you get this nice error message telling you maybe you actually meant to do function call with the parentheses. Lastly, we should support not only programming languages, but also language ecosystems. P13 went through a drastic experience going from C++ to JS, where everything is different, not just the programming language, the IDE, the source control, everything is different. So, what could we do here? Well, one idea is to use this idea of language server protocol out of Microsoft. And it's this question of, can we all agree on a protocol for common editor functionalities to tackle the IDE case? So we go from a problem of having to provide a new plugin for each new tool for each language to just language server implementation for that language, and the editor can parse that. And so this is more of a partnership between language designers and toolsmiths to create a seamless experience that reduces interference. So I'd like to conclude my talk there, and I'm open to any questions or comments you might have.